Hello, my name is Javine Flood, and I'm going to talk about Project 2, the external flow over two bodies in a test section experiment. I'll be talking about the horizontal flat plate at 60 hertz for the part 3 video, or motor frequency at 60 hertz. So we'll go here. We'll go to the bottom here. I already have everything all pre-done, so I'll just go ahead and explain it. Double click it. Make sure that it's on 2D for the analysis type. So what I did for the geometry portion was I added these name selections for the inlet outlet. So if you go here, it'll show right here the inlet. It's highlighted in green. If you go over to the outlet, it'll be highlighted in green. Make sure that the object for the geometry is highlighted as well. So the top, the bottom, the tip for the left side is what we'll call it, and the tail for the right side. So once I did that, I generated everything. You know, at each and every one, I click generate. Then you can close out of this. It should come up with just the horizontal flat plate here. You can minimize this, go to mesh. Let that load. Okay. So as you can see, the name selections are still here. All of them are showing the correct places. All right. And then the mesh, I selected mechanical, 0.005 for the element size. And then that came up with this after I clicked generate. Sizing, I clicked adaptive sizing. Yes. All right. And then all those selections should be the same, or should be default, should be fine. Click generate. All these came through. We're good to go. The materials. Oh, we're not there yet. Okay. So, all right. So then now basically we can go to the setup. And then this pulls up this dimension, 2D dimension already. Double precision is what we're looking for. Start. All right, so this is coming up now. We're going to click, once it's done, we'll be able to click OK. All right. So here we'll go energy. We've selected on for the energy equation. Viscous. Depending on if you want it to be inviscid or viscid, you can do laminar with the viscous heating. We just leave it on K epsilon for now with standard settings. Make sure viscous is off for now because we're just gonna leave it default. Actually, yeah, yes, okay, default. All right. Anyways, so all right, now we're gonna check our boundary conditions. Make sure everything here is correct. So we have the energy, the viscous. Okay, so that's fine. Now we need the boundary conditions. All right, so the inlet velocity, well, that's 4.6 with our math. We made sure that at 60 hertz was 4.6229 meters per second. Those were the calculations for that. So I had that done already. So apply. We'll make sure that the outlet is the same atmospheric pressure. All right, this is what it should be. So okay. Click close. So all that's good now. And then basically what I did was I did initialization, initialize it, and then I'd click ran calculation for 100 iterations. Calculate. I'll let that do its thing. Perfect. Okay, so now we can see down here at the bottom. Let me close this, make it easier to see. So we have the contours, we have the static pressure. What we did was we select just interior surface body only. All right, for the static pressure, we compute, save and display. You can close it now. And so this is the static pressure for the interior. And so if you zoom in, you can see it a little bit better. But all right. So then we have the velocity magnitude, and make sure that that's selected for just the interior surface body. Save and display. You can see that it changed right here. Right. And then we have the path lines. So after you do that, we can go to path lines. This is the part where you can check and see what steps in path skip you would want to use. So I messed around with it a little bit. 8 steps for path skip seems pretty decent to show like the outline of this here. If you changed it to, for example, like 50, save it. You see how everything just really accentuates. So either just keep it at 8. That way we could see a little bit clearly more in between the lines. You can mess with it however you'd like. And then, all right, so that's it for that part for the setup. Then for the solution, that should actually, that's it. All right, yeah. So my name is Javine Flood, and this is my part for the Lab 2 experiment.